And hello, how are you doing? Welcome to Cloudy with the Chance for Learning. And of course, I do this, I don't know, maybe once a week or so, but Thursdays has been usually my day. And so anyway, how are you guys doing? Hopefully you're doing good. And I'm going to try to make this as simple as I can. Now, cyclogenesis, you know, when you hear cyclogenesis, it just sounds like a big, long word, and it is a long word. But basically, it's kind of two words put together. Cyclo is kind of short for cyclone, or an area of low pressure. And there's different kinds of areas of low pressure. We've got most of those that we deal with, the little L on the map. Those are what we call mid-latitude cyclones or extratropical cyclones. And then you have the tropical cyclones. We'll get into both types and both of those. So anyway, it's fun to be able to do this, and hopefully you'll enjoy it. And I'll try to keep it as simple as possible because really it's a pretty complex topic. So, all right, first thing is the upper level pattern, you know, and a lot of folks are like, upper level, I don't even understand that. Well, of course, we all live at the surface, what we call the planetary boundary layer, which is the lowest 5,000 feet, right? That's where we live. Up above that, up around 20, 30,000 feet, that's what really determines what happens at the surface. So that's a good place to start, and that's where we'll start off. I need to log on to Facebook myself and see if I can answer some questions that you might have. Feel free to leave a question. There we go. And if you've got a question, I will try to get to it. Jennifer, how are you doing? All right, third grade, San Antonio, how are you? And let's see, Phyllis. Hello. Oh, Greenville, Mississippi. Phyllis, you probably don't remember me, but I worked at WABG, this Power of the Super Delta or something. I think that's what they call it. Anyway, that was my first job. I was getting my master's degree at Mississippi State. They needed a weekend meteorologist, and I worked over at WABG, I think is the name of it. Yeah, there in Greenville, Mississippi. And so that was way back. That was a long time ago. That was like mid-90s, 96 or something like that. So anyway, Phyllis, you probably won't remember, but anyway. And Andrea, how are you doing? Okay, so let's get to it. First of all, in the upper levels, this map is really kind of fuzzy. It's the best I could find, but anyway, you get the point. You see the United States, and I'm going to point here on this map, but you've got the other bigger map there in the other box. So we've got the upper level trough like this. East of the upper level trough, that's where you see lift in the atmosphere. If you dissect that and you go on the other side, then you have subsidence or a sinking motion. When you have that sinking motion, that means most of the time you have really nice weather. On the other side, where there's a lot of lift, it's usually more cloudy, shower storms, and that's an area that we could see our cyclogenesis, or area of low pressure, develop. Okay, how and why? Well, you got to bear with me here. Here's our little trough. Remember, this side was sinking. This side is the rising motion. Okay, so you kind of think from 3D. Say we're here at the ground and airplanes are way up here, right? Well, when that air comes around like this, you've got what we call upper level divergence, okay? It's really going. So basically, it's actually pulling air from the ground up, and that causes an area of low pressure. Usually, it's along a frontal boundary, and usually it occurs where the temperature gradient is the tightest. Usually, if you've got colder temperatures and warmer temperatures that are in close proximity, that helps to develop that low. And where you have that low develop, again, is where you have the upper level divergence. And getting some big words here, but hopefully you get the point here. So, in the upper levels, up about 20, 30,000 feet, you've got this trough. This is a surface map, again, where we live, right? So you'll have these frontal boundaries, right? And along this front, every once in a while, you'll have an area of low pressure, again, where the pressure gradient and the temperature gradient is the tightest, and where you've got that upper level divergence, and that helps to lift that air basically from the ground up into the sky, creates low pressure, and then you have an L, or an area of low pressure that develops, and that's what we call cyclogenesis, or cyclones. Here's a look. Hopefully you can see it a little bit better on your map there, but notice where the temperature gradient is the tightest. You've got temperatures here, I believe in the 30s, 20s, 40s, 50s, 60s, and then a lot of times a favored area for an area of low pressure to develop, or cyclogenesis, is along the Gulf of Mexico, usually just east of us over towards Houston. you'll have areas of low pressure develop. Why there? Well, a lot of times you'll have these frontal boundaries that come down, and because the continent is colder, well, it'll come down, and then a lot of times the Gulf of Mexico is warm, and that's where you'll have your tightest temperature gradient, where the closest proximity of colder temperatures to those warmer temperatures, and a lot of times you'll have an area of low pressure develop here in the northern Gulf of Mexico, and then it'll tend to run up the east coast. Same thing happens in the Gulf Stream in the east coast of the United States. Same thing happens there. So we've got different stages of the extratropical cyclone, okay? There's your frontal boundary right here, okay? It's like there's no areas of low pressure, but it separates cold from warm. And then you have that trough that comes across, the upper level divergence that causes surface convergence, and you'll have an area of low pressure develop. So if you could imagine, say you've got Canada here, Mexico here, well, as this area of low pressure develops, it helps to pull even cooler air down and then warmer air up, and it really kind of feeds into that area of low pressure. And then you've got the warm sector that develops, okay, where you'll have an area here where it's really warm, and then on the backside, because of the northerly winds, it's cold, and then it'll occlude. And I know that's a fancy word, but basically what that means, when you see a system occlude, basically it's hit maturity. And almost all the way around it, there's no more warm sector, winds out of the south. There's no, even though there's a northerly component to it, the temperatures all the way around are about the same. And when that happens, the low pressure, begins to die, and then that cyclone begins to dissipate and then go away. So those are the different stages, all the way from just a stationary frontal boundary to occlusion, and then dissipating cyclone. So hopefully that makes sense for you. Hopefully I'm not getting too deep. Like I said, this is a topic that you can get real deep in, and for me it's hard to keep it, fairly simple. Susan, good. I'm glad you understand. And Matthew, glad you understand. Ashley, okay, good. Airflow, the upper level airflow flows parallel to the lines. That's exactly right in the northern hemisphere. Very good. That's good. Susan, how are you doing? Matthew is only just for hurricanes and typhoons. Okay, we're going to get to the hurricanes and typhoons here in just a minute. And Shelby, I know it's complicated, but we're having fun anyway, right? Okay. All right, so like I said before, northern Gulf of Mexico is a favored area for cyclones or low pressure to develop, okay? And these are the mid-latitude cyclones we're talking about, extratropical. We haven't got to the tropical ones just yet. Mainly cold front comes down, sits here in the Gulf of Mexico. The difference between the cool here and the warm here creates an area of low pressure, and then it runs to the north and the east. And the east coast kind of does the same thing and runs up the east coast off to the north like that. So now we'll get to the fun stuff. Since we're talking about the Gulf of Mexico and the East Coast, we'll talk about the tropics. Now, earlier I had talked about how mid-latitude cyclones develop, the plain old L you see on the map, and we've got the L's and the H's and so forth and so on. Well, in the tropics, they form quite differently. The mid-latitude cyclones that I was talking about a while ago, you really need that upper level divergence. You need the upper levels to be turbulent, to be quite fast, and the wind speed's pretty fast at 20, 30,000 feet. Well, the thing that's funny, in the tropics, you really want the opposite. You want almost no movement going on up in the 20, 30,000 feet level area. You want it to be really quiet and pristine, because what you want is you want thunderstorms to build and not be disrupted. So it's kind of a interesting way that the tropics really develop. The cyclogenesis is much different than over the mid-latitude, the regular L's. Okay, so tropical cyclogenesis, how does it all begin and why? Well, around the Caribbean into the Atlantic, you've got these big ridges of high pressure called the Bermuda High or the Azores High. And around it, almost like spokes on a wheel, you'll have little weak areas of low pressure or a weakness in that high. And out in the tropics, it's humid. There's always a lot of humidity. Clouds just want to build, but they need something to build on. And these troughs or easterly waves, these are the areas that clouds can build on because the air is converging. So you'll have, maybe some showers, maybe some storms along these troughs, these easterly waves, or troughs of low pressure as they move across the Atlantic or into the Caribbean and eventually into the Gulf of Mexico. Here's another way to look at it. Here's the Atlantic Ocean. Here's our ridge of high pressure. A lot of times you get the Bermuda high. And then like spokes on a wheel, there'll be weaknesses in that high, and those are the areas that you'll have showers and thunderstorms that will develop. Now, in a regular season, we have lots of these little spokes that come around the upper level ridge of high pressure. Very few of them develop into anything tropical because most of the time above it in the upper levels you've got pretty strong winds, and that's what we call wind shear. Remember I was telling you about you don't want that. You do want it when you're talking about the continental United States or the continents to develop low pressure, but that's extratropical. These are tropical. We don't want any wind motion whatsoever. We want everything to be really quiet above. Now below, yeah, we want these showers and storms to develop. So this is what happens. Every once in a while along those troughs, those easterly waves that I was showing you, those spokes on the wheel, every once in a while the upper level winds will be really quiet, the storms will develop, and then there'll be more and more thunderstorms. Now, one thing you need to think about, here's the ocean floor, right? Here's the ocean. The sun will shine down on that ocean just continually, and energy from the sun, when it goes to the atmosphere as short wave radiation, it is absorbed by the ocean. It just doesn't dissipate. It's absorbed and ready for, it's energy basically, ready for use. So what really drives weather and what drives tropics is the sunshine. Yeah, the sun actually does it. Without the sun, we wouldn't have any weather. Of course, we'd have other problems. But anyway, so the sun with that shortwave radiation hits the water, and the water temperature warms up. That energy is stored, ready for use, and what happens is the warm water will cause evaporation, clouds will build, and then what we call latent heat is released. It's released when clouds are produced and raindrops are produced. A little bit of heat is released. Why is that important? Well, around those showers and storms, the air will be cooler, okay? And then as this inside of here, as it kind of warms up with that latent heat, air will be drawn towards it, and then more showers and storms will develop, and then you'll just have a vicious cycle. And actually, with so much lifting going on, you'll create lower pressure at the surface. And the lower the pressure, well, the more showers and storms, and then you got a pretty good cycle, and that's the way you have low pressure develop in the tropics. Really completely different than what goes on in the extratropical atmosphere. Okay, let's see. So this is the mature hurricane, okay? So you've got all of that going on. It's really going on to the max, and lower pressure is dropping, and you have more and more showers and storms that develop. You've got a lifting motion here. It's really quiet up above, so these showers and storms are not disrupted, and then they become lines, and you've seen them on the satellite imagery where you've got these feeder bands that feed into the middle of the tropical storm initially and then into the hurricane, and the whole thing just develops. And so you've got your mature hurricane there. All right, so let's see if we've got any questions. I tried to keep it pretty simple. Jennifer, how you doing? All right. And what is that? Is that like looks like a little fox? Anyway, let me know what that is. And Patrick is like, duh, right? Yep. Oh, exactly. You're right, Ruel. The warmer the ocean, the more energy. Therefore, when a hurricane does develop, the stronger that hurricane is going to be. Okay. All right. Any other questions? Nope. Well, I tell you what we're going to do then. We're going to go into the forecast. Now, it is nice. Just walked outside. The temperatures are warming up, but we don't have a whole lot of humidity. The relative humidity is going to be pretty light this afternoon, or pretty low. We're going to see those relative humidity values down to around 20% this afternoon, so that's going to allow temperatures to really warm up. So let's take a look outside. Right now it's 82 degrees, 83 degrees at Calaveras Lake, and look at all the blue. Lots of sunshine, the skies look great. But here's what's interesting. I know we're in the 80s now, but this morning it was quite chilly. Got down to about 53 for morning low. 45 at Bernie, Kerrville's down to 43, and Fredericksburg 44. Those are pretty low temperatures for the end of April, and our 53 was a pretty low temperature as well. Pleasanton got down to around 49. Temperature now, 82. Look at Kerrville. What about Kerrville already? What is this? It's 1 o'clock, a little after 1, about 1:10, 1:15, something like that. Let's see, what time is it? It's about 1:16. And Kerrville has gone from a temperature in the lower to mid-40s this morning to 82. That's a big swing. That's about as big a swing as you're going to see in half a day. It's incredible, actually. Pleasanton 82, Floresville coming in at 82. Look at Beeville, 87. Catula's coming in at about 87 degrees as well, with really no humidity. And the reason that we've seen these big swing in temperatures from 53 already into the 80s, we've already gone 30 degrees so far in just about 5-6 hours time, is because we've got light winds, we've got a lot of sunshine, and we've got dry conditions. So that's a recipe for having big extremes, both low and high. And I do think tomorrow morning will cool down. As soon as the sun goes down, you'll feel it. And low temperatures tomorrow morning will be down to 59. Look at the relative humidity values. Don't forget the chapstick. You're going to need it this afternoon. If you're going to spend any time outdoors this afternoon, relative humidity will be down to about 20% or so. That's pretty low relative humidity. Taking a look at the surface map around Texas, we've got high pressure right in the middle part of the state. And with that high pressure in place, it's giving us just wonderful weather and low humidity and light winds. When you get underneath that high, the winds are really light. And so that's why we're seeing just beautiful conditions. Now, you know, we were talking about cyclogenesis a while ago. We've got an area of low pressure over there around North Carolina. That's the extratropical area of low pressure that develops along frontal boundaries, and there you go, there's an example. All right, if you have not lived in South Texas very long, well, you're going to get to know what we call the upper level high, and this is a time where I can point this out. The jet stream is moving way to the north. That's bad news for rainfall here in South Texas, because we need the lift from the jet stream and from what's going on in the upper levels. Kind of talked about that a while ago, to create showers and storms. We're going to have almost the opposite. We're going to have the upper level ridge build in, summer-like upper level ridge building in over the weekend and into the first part of next week. So therefore, it's kind of early for this, but it's going to feel rather summer-like. Now, this is not going to be the strongest of upper level highs, but I still think it's going to cause temperatures to reach the mid-90s, maybe even upper 90s as we head into the weekend. Plus, it is going to be humid. So if you're not a fan of hot temperatures and humid and heat index, you're not going to like this weekend, because I think that's where we're headed. So high temperature today in the upper 80s. Tomorrow morning, we'll see those low temperatures cooling down. This computer model says about 62. I think we can get down to 59 or so for a low temperature. And then tomorrow we'll see those highs getting into the lower 90s, but still really dry for Friday, I think. About 91 for a high, but dry. And then as we head into Saturday, I'll kind of fast forward it, there we are. Saturday morning, about 6, 7 o'clock in the morning, I think we'll have maybe even some fog. Definitely cloud cover, and probably some fog for some of our eastern counties, but probably not for us. And then we'll warm up. Saturday's going to be in the mid-90s. So let's take a look at that 7-day. Today, 88, dry, really nice out there. Even though it's going to be 88, it's going to be dry, so not bad. Tomorrow's going to be another dry day, mostly sunny, low 59, high 91, really nice. Now here's where we start having problems. Southerly winds come really roaring back as we head into Saturday and Sunday. Humidity goes up. Highs in the mid-90s. You add some humidity, dew points in the 60s, and you're going to have heat index values above 95 and 96. I think at least upper 90s, maybe even close to 100 heat index for both Saturday and Sunday. And then Monday and Tuesday, high temperatures in the upper 90s. So it's going to be hot Saturday, Sunday, Monday, Tuesday. But here's the deal. Even though we'll have southerly winds Monday and Tuesday, I think the humidity will come down some, so we won't have such a big heat index for Monday and Tuesday. Cold front comes in early Wednesday, still highs in the low 90s, and you know we're getting close to summer when we have a frontal boundary, we're behind the front, we've got northerly winds, and the coolest that we can cool down is still 91 degrees. So that's South Texas for you, and I think, yeah, Wednesday, despite a frontal boundary, we'll still hit about 90, 91. Slight chance of seeing some rainfall. We need a better chance of seeing some rain. We may get it Thursday in day 8, but it doesn't look good for the next 7 days. So again, I guess it'd be a good day to wash the car and definitely water the lawn. All right. Well, I appreciate you joining us. We really thank you for watching us in the morning and the evenings and watching Bill Taylor in the evenings. And we definitely appreciate you in the mornings, that is for sure. So have a great day, be safe, and thanks for joining us with Cloudy with a Chance for Learning. Okay, we'll see you later.